Hello, welcome to the course of Software Defined Networking or SDN. In today's lecture, we are going to learn about Network Functions Virtualization or NFV. In the previous lecture, we studied about virtualization, the concept of virtualization, advantages and disadvantages of using virtualization technology, different types of hypervisor, the role of hypervisor. And then at the end of the previous week lecture, we shed some light over the NFV. And in that lecture, I told you that actually it is a key driving factor in the development of SDN. So it is playing a crucial role. NFV and SDN are independent technologies, but they are very much interrelated with one another. However, there is a difference. SDN, as we know, decouples the data and control planes of the network, and it actually separates the logic of forwarding from the networking devices. Actually, it makes the network more flexible and more efficient. While on the other side, NFV decouples network functions from specific hardware platforms, and it achieves this objective with the help of virtualization. So virtualization can be applied in many different disciplines, and SDN is one of them. So in this lecture, we are going to go further and to explain further the concept of NFV. The objective for this lecture is that at the end of this lecture, you would be able to understand the basic concept of NFV. What are the key benefits of NFV and what are the requirements for using NFV? And finally, you will be able to present an overview of the NFV architecture. So, a roadmap for this lecture is mentioned on the slide. We are going to revise some concept, and one of the basic concept is the concept of hypervisor. And after that, we are going to introduce NFV, the motivation behind NFV, the concepts related to NFV, and an example. And after that, we are going to go deeper and explore the framework and architecture for NFV along with the benefits and requirements. First, let us revise the concept of hypervisor. Actually, we know that in the world of virtualization, hypervisor play an important role. On one side, at the bottom, we have the physical resources, equipment, devices, hardware. And on top of that, we have a software layer that is known as VMM, Virtual Machine Manager or Hypervisor. And on top of that, we have different virtual machines. Okay, and each virtual machine may run its own operating system, and on top of that we can install different application and we can run different processes. Okay, this concept of virtualization actually lead us to the concept of NFV or Network Functions Virtualization. This is something that we are quite familiar with. We studied about this approach in our previous lecture. What NFV do? Actually, it decouples the functionalities from these devices. We have different network devices. They perform different tasks, different operations, and then we are interested to decouple those functionalities from the devices and embed them in a software approach or in the form of virtualization. So we are going to explore it in a moment further. So this is something from the previous lecture. Well, what is the NFV. Actually, here we have mentioned two definitions. I will not go into explaining or describing these definitions, but I would like to explain them with the help of a motivation. And after that, we will come back to the definition portion. So the motivation for NFV. Actually, the major network operators, they are always interested in improving their network operations. And this search for improvement in network operation actually leads to the development of NFV, or network function virtualization. And the objective for NFV is to leverage the standard IT virtualization technology. As we learn about the virtualization technology, so why not to utilize the mature virtualization technology to consolidate many network equipment types onto industry standard? Like we have different servers, different switches, different storage devices. So we would be able to allocate them in data centers, in networks, in enterprises networks or organizational networks, and even in the end user devices in order to improve the network operation. As we know that networks include a large and growing variety of proprietary hardwares, and this use of proprietary hardware in the traditional networking architecture, they actually have several negative implications. For example, if you are using traditional network environment, then new network services will require different types of hardware. If you want new services, you will obviously need new set of hardware. And then the problem comes in finding space for the new hardware, for the new server, for the new devices. And not only space, but also the power issues, to supply power and to provide cooling systems, to provide manpower for those new set of hardware. So that will increasingly become difficult. And another drawback is that new hardware mean extra cost, so additional capital expenditure. And also new hardware appliances mean that you will obviously require skills which is necessary to design, integrate, and operate increasingly complex networking environment. Another drawback of traditional approach is the end life, the lifetime of the devices that we have been installed. And there is a concept which is known as procure, design, integrate, and deploy cycle. And in return, we are obtaining very less revenue benefits. So this is another drawback. So the NFV approach moves away from dependence on a variety of hardware platforms to the use of a small number of standardized platform types. And that is possible with the help of virtualization technique. So NFV is actually an approach, and that is capable and applicable to any network. The network could be fixed network, or even it could be a mobile network, ad hoc network. So you can apply the concept of NFV to different types of networking environment. Okay, NFV concepts. Before Going into the details of NFV concept, let me give you an idea of the virtual machine and hypervisor once again, because these concepts are very much important for understanding the NFV environment. Well, virtual machines. Traditionally, applications are installed directly on an operating system. Like you are using Windows 7 and you install different application software in that operating system. And in traditional environment, each PC or server or any computer would run only single operating system at a time. So application vendors have to rewrite their applications for each type of operating system or for different types of platforms. And this will increase the time to market to bring their applications to the market, and also it will affect the quality of testing efforts, and it will also increase the prices of the applications. So virtualization technology will enable a single PC, a single computer, a single server to simultaneously run different and multiple operating systems. A machine running virtualization software can actually host numerous different applications. And the beauty is that all the applications would be running on a single hardware platform. So you can say that actually the host operating system can support a number of different virtual machines. Like in this case, you can see we have virtual machine 1, 2, and up to n. Actually, the virtualization is not a new technology that we are actually using or utilizing for the SDN. It is something that was in the IT world from 1970s. And at that time, IBM mainframe system uses the concept of virtualization and virtual machine. They allow programs to use only a portion of a system resources. Okay, another thing in the virtualization environment is the hypervisor. And that is actually a solution that will enable virtualization. Okay, so this is actually a software which actually sit between the hardware and the software. On one side we have the hardware, on the other side we have the software. So it sits between the two worlds. And it will allow multiple virtual machines to safely coexist on a single physical server, on a single physical machine. Okay, so this is the concept of hypervisor and also the virtual machine. Now these things lead us to the idea of SDN. And in the SDN, we have NFV, which is actually the backbone for SDN. So again, let us see the NFV concepts in details. Actually, the virtualization of network functions, in very simple word, is the objective of NFV. Like we have different network devices and they have different functions to perform. So NFV try to virtualize the network functions by implementing these functions in software and then running them on virtual machines. That is the main concept of NFV. The virtualization of network functions. How? By implementing the functions in softwares and by running them on the virtual machines. So you can say that NFV will decouple network functions. What are the network functions? Some common network functions are network address translation, firewalling, intrusion detection system, domain name system, the concept of cache, and plenty of other functionalities are there. So NFV will decouple all these functionalities from proprietary hardware appliances. As you can see, we have different appliances here, each with specific functionalities. So the functionalities will be decoupled from these proprietary hardware appliances so that they can run in software on top of virtual machines. Virtual machine technology can be applied to network-based devices. What are those network devices? Actually, we can roughly categorize these networking devices into three categories. The first category is known as network function devices. The second category is known as network related compute devices, while the third category is known as network attached storage. The first one, network function devices, are devices like switches, like routers, and like access points. All these came under the category of network function devices. And then we have network related compute devices. For example, your firewalls, intrusion detection systems, network management system, and things like that. And then we have the storage, network attached storage devices like file, like database servers, like other type of storage devices that are actually connected to the network for the purpose of storage. So what happened in traditional networking, all these devices are deployed on proprietary softwares, proprietary hardwares, platforms. And each device requires additional hardware for increased capacity. Okay, so if you want to increase the capacity, you have to spend more money. But on the opposite side, if that hardware is not utilized by the system, then the system is running below its capacity. So the hardware is not in use, idle, wastage of resource. That is a problem in the traditional network. With NFV, network elements are independent applications, programmability, and they are deployed on a unified platform. As you can see, we have a unified platform here. Okay, so this unified platform, and by using this setup, software and hardware are decoupled, and the capacity of each application is increased or decreased by adding or reducing resources, because the resources now are virtual. So you can add more resources if required, and you can reduce the number of resources if they are not required anymore. Okay, so this is actually the concept of NFV that I explained. Now let us see a simple example which will demonstrate the use of NFV. Actually, this figure shows a physical realization of a network service. At the top of this figure, you can see the network service, which is consist of endpoints, like we have endpoint 1 and endpoint 2, and these endpoints are connected by a network functions block. NF stand for network function block 1, network function block 2, network function block 3, and this is referred to as a forwarding graph. So you can see this NF1, 2 and 3 actually make a forwarding graph, and this forwarding graph actually connects the endpoints. What are these NF? What are these network functions? They are actually any devices like firewalls, like load balancer, like your access points, like your switches, etc. So in the architectural framework, these NFs are viewed as distinct physical nodes. Okay, we will be interested in these NFs. The endpoints are not concern of the SDN, and they are normally the scope of the NFV as well. NFV have different specifications. Their focus is on the NFs, not on the end points. So in this figure, endpoint A, it could be any device ranging from a laptop, from smartphone, to a server, to a notebook, to another computer and things like that. So actually you have a client, for example here, and you have a server which is providing the contents, and these two devices want to communicate. So we have a network function forwarding graph here. Okay, this diagram also highlights the network functions, and these network functions are actually relevant to the service provider and the customer. And you can see there is an interconnection between the network functions. The logical links are here. Okay, they are interconnected with one another, and also they are interconnected with the endpoints. As you can see, they are depicted by the dash line. They actually represent logical links, not the physical link. These logical links are supported by physical paths because we have the actual infrastructure beneath it. And it could be wired or it could be wireless. So to further elaborate the concept, let us see a more detailed view. Now here we have a virtualized network service configuration that could be implemented on the physical configuration of the previous graph or of the previous figure. You can see we have different virtual network functions now. Okay, like we have VNF1, we have VNF2, and we have VNF3. VNF1, it actually provides network access for endpoint A, for example. And VNF3 will provide network access for endpoint B, for example. The figure also shows us a nested VNF forwarding graph. Remember the concept of forwarding graph from this figure? Actually, this is the forwarding graph. So here we can see we have a forwarding graph, and there is like a nested forwarding graph, a nested VNF forwarding graph, and that is VNF forwarding graph 2. And then we have A, B, and C. Okay, so there is like a nested VNF forwarding graph. And this is constructed from other VNF. Okay, so all of these VNFs run, you can see, on top of the physical hardware. So here is like virtualization. You can see the virtualization layer here. The color is like pink. So these VNF are also pink, which means virtualization is there. They run on top of the virtual machines, and virtual machine run on top of the physical machines. And those physical machines are called POP, which stand for point of presence. Okay, again, let us see how they are interconnected. The first VNF G forwarding group 2A, that is actually connected with NFV. Sorry. So the first one is actually connected with network function VI, sorry. Or you can say VNF1 is actually hosted on this machine. And here you can see two VNF forwarding graph A and B. They are actually hosted on the same physical machine. As you can see the blue dash line, they are actually hosted on the same physical machine. Why? because these two virtual machines may perform different functions. They need to be distinct at the virtual resource level. Okay, here they are performing different functions. Okay, so they have been differentiated. One is A, one is C. But they can utilize the same physical machine at the physical level. Okay, so at the physical level, they can be hosted on the same physical machine. Another important point to remember here is that at some point, your network management function may require to migrate one of this virtual machine to be hosted on another physical machine. Maybe for performance reason or maybe for other reason. So that is possible. Not only possible, but that moment of the virtual machine migration should be transparent to the user and also should be transparent at the virtual resource level. Another point to remember about this VNF is that here you can see a nested virtual network functions A, B, and C. Actually, the reason for the separate machines is to provide different network functions. For example, it may be possible that some traffic flows need to be subjected to some traffic policies, and that could be performed on this VNF 2C virtual network function. For example, this node is providing some policies which is related with traffic flows, and that could be performed at this VNF2C. So some flows would be routed through this 2C, while others could bypass this network functions and maybe they follow another route. So different functionalities can be provided at different VNF nodes. There are some NFV principles. Okay, there are two terms, and that is important to remember. First is that the keyword VNF, virtual network functions. And the second one is NFV, network function virtualization. So network function virtualization is the broader term, the technology, while VNF is actually the functionality which is provided in virtual form. So NFV, it has some principles. And what are those principles? The first principle is service chaining, which means that VNF are modular in the sense that each VNF will provide limited functionalities on its own. As just we saw here, in this case, we have applied a modular approach. Even if it is a single VNF forwarding graph, we have another like 1, 2, 3. Consider them a single, just like this 1, 2, 3. So this is like a modular approach, but attached, connected with one another. So VNF are modular, and every VNF will provide limited functionalities on its own. This concept is actually referred to as service chaining. But for a given traffic flow within an application, the service provider actually steers the flow through multiple VNF. Maybe This endpoint want to send a packet to this endpoint B, and the packet will have to travel to NF1, then NF2, and then NF3, and then finally will arrive its destination. So for any given flow, it is possible that the flow will go through multiple VNF to achieve the desired network functionality. And this is actually known as service chaining. The second principle is uh, management and orchestration. And this actually involves deploying and managing the life cycle of VNF instance. For example, the creation of VNF, the service chaining, monitoring, reallocation of any VNF, shutting down an VNF, or billing information for using the virtual services. So this Mano will actually manage the NFV, network function virtualization infrastructure elements. And finally, we have a third principle, that is distributed architecture, and this is simple. VNF may be made up of one or more components, virtual components, each of which will implement a subset of the functionalities. So they are deployed on different machines and they cooperate with one another, so they are distributed in nature. Okay, now after discussing the principle, let us see a high level NFV framework. This will describe the above scenario in a more detailed view. It actually shows a high level view of network function virtualization framework, and this framework was defined by a group, and that group is known as Network Functions Virtualization, NFV, Industry Standards Group, ISG. So ISG stands for Industry Standards Group. They actually define this framework which we are going to explore now. So this framework will support the implementation of network function. Actually, NFV is about the decoupling of the network functions. So if we decouple them from the hardware, we need to implement them in the software. So how we are going to implement them in the software? This framework will support the implementation of those network function as a software only VNF. Okay, what's here? This framework consists of three domains or three layers. The first one is the network functions, which is known as VNF. And we studied about VNF here, okay, VNF. So this is the first domain. The second one is the infrastructure, NFV infrastructure, the second domain. And the third domain is about management and orchestration. That is the third domain. The first domain is actually the collection of VNF. You can see we have a collection of virtual network functions. And all these VNF are actually implemented in software. And they run on NFVI, Network Function Virtualization Infrastructure. So we have an infrastructure here, and you can see this is a common infrastructure. Although it is a virtualized environment, the actual physical environment is here. We have computing hardware, on top of that we have virtual computing. We have storage hardware, on top of that we have virtual storage. We have network hardware, and on top of that we have virtual network hardware. And that is possible with the help of virtualization layer. So domain number one is a collection of different VNF, and they are implemented in software, and they run over this infrastructure. Now what is this infrastructure? That is the second domain. This virtual network function virtualization infrastructure actually performs a virtualization function. And this virtualization function is performed on three main categories of devices in the network environment, and those are computer devices, storage devices, and the network devices. And we need management as well. For that, we have the third domain. It actually is related with the management of the life cycle, as I just talked about the life cycle in the previous slide. So the management of different physical and software resources that will actually support the infrastructure virtualization, and also the management of virtual network functions. Okay, so all the management activities that is happening in this domain, which is domain number 3. Now let us see some benefits. If we use network function virtualization, what are the benefits? So the first benefit is the cost reduction. Capital expenditure will be reduced if we are using this network function virtualization approach. Why? Because if more resources are required, then you are not going to buy the actual hardware. You are actually using virtual hardware, virtual network resources, virtual storage devices, and things like that. So you can say that it is like pay as you go model or pay as you grow model. If you need more resources, just acquire them from the virtual environment. So it will eliminate the wasteful over provisioning of resources, and it will reduce the capital cost. Not only the capital cost, it will also reduce the operational cost or operational expenditures. What are those? Like the power consumption, the cooling system, the space required, commodity hardware, software, commodity services, switches, not software, sorry, hardware, servers, switches, routers, and other components. So actually, the NFV approach will reduce network operational cost as well. And it will also reduce the deployment time. It will reduce the time to deploy new networking services in order to support the changing requirements. The business requirements may change from time to time. Okay, so if you are using virtualization technologies, you actually improve the investment, the return on the investment of new services. You deploy new services in the software using virtualization techniques, and then you get return on your investment. Okay, another advantage is interoperability because of standardized and open interfaces. It is now possible for different services to interoperate with one another, to cooperate with one another. And resource sharing obviously is another advantage, which means that use of a single platform for different applications, for different users, for different tenants. This actually allows the network operators to share resources among different users, among different customers on need basis. So you can actually share the resources, and that is one of the advantage of using virtualization, including NFV. Flexibility is also there. Like if you want to scale the system, or if you want to downscale the system, that is possible. So change on demand is possible and easily achievable. Targeted services, like providing services, for example, based on the geographical location of the customer, it is possible. Services can be rapidly scaled up and scaled down based on any geographical area as required. So you can provide targeted services. And finally, openness is another advantage, which means a wide variety of ecosystem, and it also encourages the openness. How? You have some researchers working in the academia. They are encouraged to test their solution by using NFV. because of the openness. New services, if you want to deploy them in the virtual environment, you can do that due to the openness. So you can test new solutions. Even small players, small researchers from the academia, they have the option to test their solutions because of the open interfaces and open standards and things like that. Now let us see some requirements for NFV. If we want to implement NFV, what we need? The first requirement is portability and interoperability. As we know that we are dealing with the hardware from different vendors. So the challenge is to define a unified interface that will be able to decouple the software instances from the underlying hardware, and that underlying hardware is from different vendor. Okay, so an important requirement is to consider this portability and interoperability. Second requirement is a performance trade-off. NFV approach is actually based on industry standard. As at the beginning I just mentioned that it is an effort from different network operations. Big industries are involved. So NFV approach is based on industry standard hardware, and that is avoiding any proprietary hardware. For example, if you are using proprietary hardware, then they use different acceleration engines. So in case of VNF, a probability is there that it will decrease the performance, and this requirement has to be taken into account. Now the challenge is how to keep the performance degradation as small as possible, and that is possible by selecting the appropriate hypervisors and by selecting the modern software technologies, modern APIs. Another requirement for the deployment of NFV is migration along with coexistence. So your VNF, your NFV, it must support a migration path. And that migration path is from today proprietary physical network appliances based solution to more open standard based virtual network appliance solution. You have to shift from the physical world to the virtual world. And your solution NFV deployment must work in a hybrid network. Okay, so in the coming era, there is going to be a hybrid network architecture. Your network setup will composed of the classical physical network appliances as well as the virtual network appliances. So there is going to be like a hybrid environment. Your solution must be able to work in that environment. It has to deal with the classical network setup as well as with the virtual setup. Next thing is management and orchestration, and we talk about it that actually this is the responsibility to manage the architecture, to manage the functionalities, to manage the virtual world, and it must be aligned, it must be achieved by using different interfaces, like we studied the northbound interfaces and southbound interfaces and things like that, and also the abstraction, the virtualization that is possible. Automation is another requirement. NFV will scale, okay, with the passage of time, requirement change, so we have to scale the NFV. So it means that the functions can be automated, and this automation is going to be a step toward the success of NFV deployment. Like if the functions are able to adjust themselves automatically to the changing environments. Security and resilience is everywhere. Means The proposed solution must be secure enough that customer can trust on it. The availability of their network should not be impaired when the VNF is implemented. So the new solutions that are based on VNF, that must be secure, and they must make available the network to the end customer all the time, 24/7 a day. Stability is another thing. We need to ensure stability of the network. As we are dealing with a large number of virtual appliances between different hardware vendors, and we are using hypervisor as well. So this is particularly important, okay, that your network must be stable. Why? Because sometime you would need to reallocate the virtual machines. Sometime you would need to migrate the virtual machines. Sometime you would need to reconfigure events. So all these factors must not affect the stability of your network. Or you can say your system must be available during maintenance or during different configurations. Okay, or you can say your network cannot be fail. It must resist different types of attack. Simplicity is at the heart of NFV. What does it mean? Simpler to operate. It must be simple to operate as compared to today's complex network. So simplification is the key to success. And you would not believe this statement, but it has been proved that systems which are more simple are actually more secure as well. And then we have the integration. Integration, as the name indicates, network operators need to be able to mix and match servers from different vendors. What does it mean? Mix and match. Hypervisor from different vendors and virtual appliances from different vendors. They need to be integrated very easily without incurring significant integration cost or maybe avoiding any lock-in. So your NFV solution should offer integration services and maintenance. So it is possible to resolve integration issues between different vendors, between different parties, between different third party brokers. Integration of services must not be an issue in case of an FV. Okay, so for example, you have different vendors and you are offering a solution. So that solution must be possible to integrate it with all the vendors. Okay, at the end of this lecture, here we have another complicated NFV architecture. This is for reference purpose. This is actually a mirror of the previous framework that we saw here. We have the same domain, but in more details. What we have here is actually more components, sub-components, you can say, or sub-modules or subdomains. Let me highlight some main point. We have NFVI. We have NFVI. So the same thing, but it is elaborated here in this architecture. Network function virtualization infrastructure, and it actually comprises the hardware and software resources that create the environment in which VNF are deployed. It actually virtualizes the physical computing and storage and networking. Remember the three things: computing, storage, and networks. Okay, so they are actually virtualized and they are placed on top of the virtualization layer. So at the bottom you have the actual hardware, and then we have the virtualization layer, and on top of that we have the virtualized computing, storage, and network environment. And as a whole, this is referred as NFVI. Second thing is VNF EMS. VNF and EMS. Virtual network function and EMS, element management system. Actually, all these terminologies are defined in this reference architecture, but we will not explain them here. Okay. So this is the second component, which is composed of two submodules, VNF and EMS. And EMS is for element management system. And the third important thing is, as we know, the management and orchestration, and that is known as NFV MANO or MANO, management and orchestration. It's the same thing that we saw here, management and orchestration. So we have here. And finally, we have OSS and BSS. This is actually something new, and it is like the operational and business support systems that is implemented by the VNF service providers. So again, this first portion, NFVI, the infrastructure, it is made of the hardware and software resources that actually creates the environment in which the VNF are deployed. And the second thing is actually the collection of VNF. They are actually now implemented in the software, and they are actually run on virtual computing, storage, and networking resources. And the second module is EMS, actually a collection of element management systems, and you can see they actually manage this VNF. And the third component is about management, a framework for the management and orchestration of all the resources. You can see it has linked with all the resources. For the physical, for the infrastructure, we have a link here. For the software functions, we have a link here. And for the policies, the operational, the business support, we have a link here. So it is actually responsible for managing all the domains. Okay. And also, you can see that we have different points here, like execution, like main points and other reference points, and different symbols are used for them. Okay, inside this management menu, we have three components: orchestrator, manager, and the infrastructure manager, VNF manager and infrastructure manager. So orchestrator is actually responsible for installing and configuring new services and also new VNF. On the other side, the VNF manager is actually oversees the management, the lifecycle management of the VNF instances. And the third submodule, it actually controls and manages the interaction of a VNF with these components: computing, storage, and network resources. So it is under the authority of this VNF, virtualized infrastructure manager. So this is a reference architecture. If you are interested in these interfaces, in these reference points, you can explore this architecture on the internet and go into the details as well. So this was about VNF from a bird's eye view. I hope you have learned something from this lecture. Thank you so much for watching the lecture. Take care and goodbye.